Hello and welcome to Hacker Heap. In this video, we will look into how quicksort works. Quicksort is one of the most popular sorting algorithms. We will look into how it works. Before we start, please subscribe to the channel Hacker Heap if you haven't already. So let's look into how quicksort works. Quicksort works with a divide and conquer pattern. In quicksort, we take a pivot element. It could be any element in the range. So let's say if we take a pivot here, and we have our left and right initially as the first element and the last element. Quicksort, how we do is once we pick the pivot, we will move all the elements that are greater for pivot to the right side and all the elements which are less than the pivot to the left side. So if we check here, we know 8 is greater than 7. So what we do is we swap these two, and the subsequent array would become 0, 4, 5, 3, 2, 7, 9, 8. We did it pretty fast. Now if you see, all the elements on the left side are less than 7 and all the elements on the right side are greater than 7. So this particular index is already sorted. Now what we need to do is we need to pick a pivot here and we need to move all the elements which are less than 5 to the left and all the elements, if there are any, move to the right, and we do the same thing on the right hand side. So we are doing a divide and conquer. Once we got one pivot point sorted out, we will divide the array, the left array and the right array from the pivot and apply the quicksort algorithm on both sides. So if you look into the algorithmic point of view, how we do is we will do it recursively. So how we do quicksort is by just using 4 steps. The step 1 is to select the pivot. Just choose your way on how to select a pivot. And step 2 is to partition the array on basis of the pivot. As we said, we will move all the elements, all the numbers which are greater than the pivot to the right side of the array and the elements that are less than the pivot to the left side. So step 2 is to partition the array based on the pivot, And step 3 is to apply the quicksort on the left partition, apply QS on left partition where the elements are all less than the pivot, and step 4 is to apply quicksort on right partition. And we recursively do these 4 steps until we had a sorted algorithm, or until the left index is less than right index. So let's go ahead and look into how the code looks for quicksort algorithm. I'm here on my lead code where I opened this problem to sort an array, and I will use a quicksort to sort an array here. So as we talked, there are only 4 steps that we need to do recursively. So for this, I want a function which takes in, I will call it a quicksort function, which takes the array and the left index and the right index. Take this as a result. And what I do is I will call this function quicksort with result, the left index 0 and the last index would be length minus 1, and all I do is return the result, nothing else. This quicksort, we have to do it recursively. Let's say if the left index is greater than or equal to right, all we need to do is just return. We should stop the recursive algorithm here. Now int mid is used to partition the array into 2 different parts, the left part and the right part. For this, I will use a different function called partition, where we actually move everything that is greater than the pivot to the right side and less than the pivot to the left side. So that's done. What we need to do, as we talked earlier, is we need to call this quicksort repetitively for the left array and the right array. So nums left comma mid. Similarly, I will call quicksort recursively for the right array. Pivot plus, sorry, mid plus 1 comma right. Now all we need to do is implement this partition where we are selecting a pivot and trying to move all the numbers that are less than the pivot to the left side and all the numbers that are greater than the pivot to the right side. So let's go ahead and write the function. For the sake of simplicity, I always choose the leftmost number as the pivot so that I will make sure that all the elements to the right of the first element are greater than, or vice versa. So now I need to loop this while left less than right. So now what we need to do is while left less than right, and let's say if nums of right is greater than or equal to pivot, we don't have to do anything. We don't have to swap the numbers. So all I do is I will reduce the right index. And once we came out of this loop, all I will do is nums of left is equal to nums of right. At this point, when the loop exists, what happens is nums of right is actually less than pivot. So what we are doing is we are changing the nums of right index to the nums of left so that it's before the pivot. So now that's done. Similarly, we need to do it from the left side than right, and I need to make sure all the elements on the left side are less than pivot. I will increase the left index when the left element is less than pivot. I will keep it where it is and I will just increase the index so I can compare with the next number. So once this exists, what I do is I will write. Similarly here, when the loop exists, the number at the left index might have been greater than or equal to pivot. So I need to move that number to the right side of the pivot element. So that's all I am doing. So once I am out of here, I'm again assigning nums of left to pivot, and I would return left. So the reason I am returning the left index is at this point, left index, all the elements to the right of this left index are greater than this element, which is actually the pivot, and all the elements towards the left of this index are less than the left. So this particular index is sorted out. So what we are doing is we are taking it as a mid element. Now we are doing the quick sort to the left and right of this index. This particular index is sorted out. Similarly, the next time whatever pivot we will choose, that will be sorted out and we will just return the left index. So let's go ahead and run this code. I had a typo here. Yep, it went through. That's good. So let's revise what we actually done. So as we talked in the algorithm, all we are doing is we are doing the step 1 where we are choosing the pivot element by using the partition, and step 2 where we are doing the partitions, moving all the elements of the pivot onto the both sides of the pivot depending on if it's greater than the pivot or less than the pivot. Step 3 we are doing quicksort again to the left side, and step 4 we are doing the quicksort to the right side. Here if you compare, what we are doing is for every index I'm making sure the element to the right is always greater than the pivot. If it is greater than, I'm just reducing the right index, and if it is not greater than, we are exiting the loop and all we are doing is moving that element to the left index. Similarly, we are doing on the left side, we are making sure all the left elements towards are less than the pivot element, and once that is done, if any of the element is greater than the pivot, we are moving it to the right side. Once we exit of the loop, the initial pivot what we grabbed, we are assigning to the left index, and this we consider as a mid, and we are sending it back. So let's take a simple example, right? Let's take this example of 5 4 3 2 1 0. So initially what happens is pivot is 5, so we are making sure so numbers at the right are greater than or equal to pivot, which is not, at this index is not greater than this. So what we did is numbers of left, which is 0, is equal to right, so it would be 0 4 3 2 0. Don't worry, we are holding number 5 at the pivot, so we will replace that later. So now, and then what happened is once we came down here, left is still at 0th index. We are making sure left is less than 5, which is true. 4 is less than 5, which is true. 3 is less than 5, which is true. And 2 is less than 5, which is true. And this is 5. Left is here now. And what I did is I replaced this with 5. So the array became 0 4 3 2 5. Now I am returning this left index. So the left index, the mid would be 4. Now I'm doing everything to the left, so I will only do quicksort on this array, and there are no elements to the right side, so I'll just do quicksort on this array similarly. Now I will pick this and I will do the similar operations recursively. When it ends, we will come up with the array 0 2 3 4 5. So this is how actually quicksort works, and it is one of the fastest sorting algorithm than any other algorithms that we had. I hope it's clear. Now we know how quicksort works, and we have already seen how to implement the quicksort algorithm. I hope it helps you solving sorting algorithm problems using quicksort. Please don't forget to like and subscribe to the channel Hacker Heap. I'll be posting more videos related to algorithms and data structures. Thank you for watching.